Hello and welcome to another National Road Safety Partnership Program webinar, the implications of weight on the mobile office. My name is Jerome Carslake and I manage the NRSVP and its many activities. So to find out more, please visit the website and register for the newsletter and you'll be kept informed of all the many things up and coming. So today's session, we'll go for approximately 60 minutes with plenty of time for discussion throughout. We have quite a few question points to hold through. And we'll be recording today's session, which will be shared through the NRSVP website and always freely available afterwards, as will the PowerPoint. So, as we run the webinar, we really welcome your input. So please send through your questions, type them in the box here, and we will hold them through and fire them away at Dave, who is excitedly looking forward to this. And talking about Dave, let's move on to our presenter today. We have Dave Schneiders, Pedders Senior Executive for Sales and Operations. Welcome to you, mate.
Thanks, Jerome. Glad to be here.
Dave has quite an incredible history. He spent his adult life in the automotive industry, so you've seen a lot of change over that time, no doubt.
Yeah, a fantastic amount, and headed in the right direction, I'm glad to say.
A great news story. So commencing 18 years ago with Kmart Tyre and Auto, he moved on to borrow repairs, and he soon found his niche and settled in with the Pedders Group over 3 decades ago. So there's some loyalty for you. Dave has a wealth of experience collected along the journey from experiences including multi-franchise ownership, extensive motorsport involvement, culminating in driving a Formula One in Italy. Not many people can boast that, actually hardly anyone. In recent years, David has focused his efforts on supporting the Automotive Aftermarket Association, AAAA, in its endeavours with government to change regulatory. Driven by his passion to improve the awareness of legally compliant weight management on our roads, David has worked in conjunction with colleagues to develop and patent software designed to stimulate load placement and legal compliance. Must admit, I've seen the software, it's fantastic. And so, over to you, Dave.
Thanks, Jerome. Okay, so today I wanted to go through what we consider to be the 7 really critical steps in fleet and vehicle selection when it comes to load placement and load management. So we'll just quickly run through what those implications of weight on the mobile office look like. Number 1 is vehicle selection, which is obviously a critical step in the process. Getting this wrong can be very costly and severely impact workplace safety, amongst other things. Number 2 is legal compliance, and we'll touch on some of the industry jargon, specifically definitions and terminologies and how they can impact your fleet. Try and give you a better understanding of that space. Chassis dynamics. The weight of accessories and payload is an obvious requirement in most fleets, but where you put it can have a massive impact on the vehicle behaviour. So we'll delve into that a bit further for you. Flowing on from that, suspension travel. Unlike the fuel system, there's no gauge on the dashboard to tell you when you're running low on suspension travel. We'll discuss the implications of weight in this key area. Wheel alignment. So the alignment angles are changed by any change in vehicle ride height. It's impacted on those critical alignment angles. We'll look at how the load and its placement impact on this area. Flowing on from that is the correct alignment angle, tyre contact and steering effectiveness are all an integral piece in keeping the vehicle safe on our roads. And braking efficiency and stopping distance. Pretty simple. Make a car heavier, increase its mass, you increase its stopping distance. You may be surprised by just how much.
Let's get into it.
So let's move forward. Let's have a look at number 1, which is vehicle selection. In any work environment, it's obviously an obligation to ensure that it's safe and fit for purpose. It should be paramount. When the workplace is mobile, the importance of decisions around those selections and the modifications become really critical. So one of the often critical key points is payload, and it's really important. Payload is the legal amount a car can carry, whether it be a sedan or a utility or even a truck, above its curb weight or its empty load. So it's normally associated with commercial vehicles, but it does need to be thought of when it comes to sedan and passenger vehicles as well. So if we have a look at, and I did a quick search on the web, and I came up with a couple of vehicles. So if we look at an SL model Camry sedan, it's got a payload of 470 kilos. So that's the maximum of occupants and luggage or whatever. That's the maximum combined weight it can have. At 470 kilos, it's a reasonable amount. What I found though was Suzuki Ignis, which is a smaller vehicle, actually has a higher payload. So size doesn't necessarily indicate carrying capacity or payload.
What's the big differentiation between those two vehicles? Why is that?
Manufacturers spend an awful lot of time and money engineering and complying their vehicles, and the axle capacities are set those by those engineers as being the safe level for carrying payload. So whatever they set that at, depending on their testing, it may be that because the Ignis is a shorter wheelbase, it can carry a little bit more over those axles. That'll be a question more for the OE engineers as to why they've come up with those figures. But suspension design certainly plays a part in that, whether it be a coil spring independent suspension or a leaf spring traditional suspension. And in the case of the really heavy articulated vehicles, they run to an air suspension system.
Okay.
So if we think about the payload, the Australian design rules for registration allow for 68 kilos per person. So the problem with that is, unfortunately now, and I'll apologise to the ladies on the broadcast straight away, the average Australian female apparently now weighs 71.1 kilos. So we're behind that 8 ball straight away. The average male is 85.9. So we're on the wrong side of the equation. I can tell you I'm north of 85.9, so I'm part of the problem.
I'm just under at 85.5. Yeah.
On top of this, passenger vehicles have to have a cargo load for personal effects of 13.6 kilos as part of the Australian design rules. So that's quick addition is 81.6 kilos per person for a passenger vehicle you've got to allow. So, but if you weigh 90 kilos, that equation's not really ever thought of in the modern day workplace or even in social environment. You know, you don't just stand there and go, I need to fit my 4 friends into the car with me, but one of them's a bit big. He might have to get an Uber. So when you're looking at the build of a light commercial fleet with the previous comments in mind, things get really interesting. So I've just dragged this picture off the net, and it's a wonderful resource. This vehicle has a GVM theoretical of 3,200 kilos. So that includes the total weight of everything, including the obviously the vehicle. So the vehicle here in this case weighs 1,951 kilos. So if we take that off, the remaining payload is 1,249 kilos. So let's look at an average service build for a light commercial vehicle. Let's put a service body on it. 488 kilos is an average size. I've heard smaller, I've heard bigger. So now we're down to 761 kilos.
And that's without tools or anything?
That's without tools or anything.
Okay.
So I've heard of service bodies. In fact, I'm first-hand experience of service bodies at 530 plus kilos. So, you know, that's a mean average for that sort of vehicle. So this is a utilities company, so they need to put a bull bar on because they're up in the country all the time. That's about 60 odd kilos worth. Now we put a winch on because they get stuck in places they need to get out of. Now we're down to 664 kilos in payload. Of course, it wouldn't be an Australian ute unless we put a tow bar on it. Now we're under 620. Now, obviously with modern communications, we've got to have a radio system. We've got to be able to get back to base and find out where the next job is or anything like that. So we put a radio system, an aerial and wiring in. And we've got a bit of space on the roof, and all of these things for some reason seem to have a roof rack on them. So let's throw that on there. And it starts to build up, and that available payload is starting to drop noticeably. Remember, we started when we took the vehicle away and just put the service body on it, 760 odd kilos. So
whittled it away pretty quickly.
Yeah. So now if we look at this goes on site. So it's got to have the warning light for the mining sites and such. So we put that on there. And last but not least, let's put a water tank because the guys need to be able to wash their hands. So we look at, sorry, lost my train of thought there. We look at this and go, okay, 541 kilos remaining, and that's a reasonable amount. But the problem is that at 541 kilos, this vehicle actually can't legally be registered on the road. And the reason for that is the Australian design rules say that, as we touched on earlier, you've got to allow 68 kilos per seating position. So in this case, even though it's a 2-door, it's actually got 4 seats because it's what they call a super cab. So you've got to allow 68 kilos by 4. When you do that, to be defined as a commercial vehicle, that total, which is, quick math, 272 kilos, has to be equaled or bettered by the cargo capacity. So you don't need just 272 kilos for the passengers, you need 272 kilograms for the cargo as well. That gives you a total of 544 kilos required, and the payload on this scenario is only 541. So technically, can't be used.
It's a real problem straight away.
Straight away. Now we'll move from there now, we'll move on to that there, as I just said, the seating capacity at 68 kilos. Now that normally is checked when you first register a vehicle. When you first register a cab chassis vehicle, because the build of the vehicle isn't known when it's supplied, you have to get a weighbridge certificate and take it in when you register the vehicle. And I do know that vehicles are being picked up by regulatory authorities around Australia as not being able to comply. So it is something that people do need to bear in mind.
Can I just rip those 2 seats out in the back?
You can, but then you need to get it re-engineered to a 2-seat as far as I'm aware. Because if it's complied federally as a 4-seat, that's what it is, unless you recomply it as a 2-seat.
Okay.
Any questions on that, Jerome?
Certainly. Got one here from Frank. GVM upgrading. Is it available pre and post registration? Would you like to comment on that?
Yeah, sure. So GVM upgrades are available both pre and post registration. We've got a bit of a fragmented system in Australia where if a vehicle has never been supplied to market, new, never registered, it comes under the Federal Act and the federal system. So as a second stage manufacturer, and there's quite a few in the aftermarket, we can comply that vehicle to the higher GVM rating. And that's all done in-house and through our quality control systems. If it's post-registration, the system in every state and territory is just about different. And a lot of those systems require a third-party engineer to sign off on it. And if that's the case, the only difference ostensibly is that that's going to increase the cost to the end user because you're involving a third-party engineer who obviously needs to get paid fee for service.
You mentioned each state can be slightly different. Does that create issues with regards to the vehicles moving over borders?
Strangely not, because some states recognise, all states recognise a legally registered vehicle in another state, even if it doesn't comply with their rules. I've never heard of a vehicle from New South, for example, being fined or put off the road in Queensland because it didn't comply with the Queensland law.
All right. Okay. Question here from Matt. If the OEM engineers are in a position to provide clear maximum load weights, why do organisations such as yourselves allow up to 600 kilograms of additional weight on vehicles without consideration of the vehicle standard braking system?
Actually, it's one of the critical things, and thanks, Matt, for the question. It's one of the critical things that all the aftermarket people do consider. One of the first things we do is test the braking system under the extra load to the new GVM to make sure that it's safe and complies with the Australian design rules. The other thing that we're doing with a lot of our kits is rolling out upgraded brake pads as a part of the kit to help compensate with that extra weight. Fantastic question, Matt.
Do you find those brake pads, do they add additional weight to the vehicle at all, or is it just
no? They don't change the weight per se. What they do is the compound of the pad, and it's like the suspension. It's like changing the suspension because a vehicle is designed to operate at a mean average. It has a minimum and a maximum. When you're operating at a maximum in any engineered field, you're going to get wear quicker and suspension sag and so on. It's the same with brake pads. You just can't see the change in the brake pad. So an increased brake pad, and we're rolling those out, as I said, across the Ford Rangers and other kits for exactly that reason that Matt said. We need to take a critical look at the safety of the vehicle. And although in the case of the Ranger, with the extra weight added, it still passed the Australian design rules, we took the decision as a company to put heavier pads on, just to make sure.
Excellent. And there's just a question came through around a query around axle limits, and we'll be touching on that a little bit later on in the presentation. All right, let's continue on.
All right, so legal compliance, and there's a lot of jargon in this industry. We love our jargon for some reason. And so I thought I'd just run through that. So we have tare weight. So tare weight's the weight of the vehicle ready to drive with 10 litres of fuel. Curb weight is exactly the same, except they've managed to find enough money to fill the fuel tank up. GVM, we just touched on, gross vehicle mass, the maximum amount that car can weigh. Payload. Payload is simply the difference between GVM and curb weight. So if you subtract the curb weight from the GVM, whatever's remaining is the payload. The payload in a light commercial includes occupants. And as we said earlier, that's calculated at 68 kilos per person.
So there's a bit of wishful thinking there as well.
Yeah, there is a little. I think these might have been, the ADRs might have been drafted up in harder times when food wasn't as abundant. So the next one is front GALR, or gross axle load rating. And that's the specification for the maximum load that can be transmitted through the front axle to the road surface. Then we have rear GALR, exactly the same thing. Now those load ratings are specified by the manufacturers, and sometimes they add up to the gross vehicle mass, sometimes they don't. And dependent upon what accessories you put on, as to where that weight should be placed. Next, we'll get the trailer in, and we have tow ball download. Now this is a specification normally set by, it can be set by either the vehicle manufacturer or the trailer manufacturer. So you can actually have two different ratings, at which point the lower rating is the one you need to look at. So if you've got for example, this is a Toyota Hilux image. If you've got a Toyota Hilux that has a tow ball download rating of 350 kilos, and the trailer says, I can have 400 kilos on my tow ball, you still have to go by the car at 350 kilos. All right, so ATM, or aggregate trailer mass. That's the maximum amount the trailer can weigh when it's on its own, basically. So through the tow ball and through the axles. Gross trailer mass, or GTM, is how much the trailer can weigh when it's connected to a vehicle. So just the amount of weight transmitted through the axles to the road surface. Towing capacity unbraked, Australia, the trailer category is TA, I think, from memory, and that's 750 kilos. So the maximum a trailer can weigh, GTM, gross trailer mass, when it's hooked up to the car, is 750 kilos.
And does that matter whether it's tandem or single axle?
It does actually, yes. Yeah, I double checked that last week, and it is a single axle rating only. TA category is single axle only.
Okay.
All right, so if we look at brake towing capacity, maximum is 3,500 kilos. That's the next trailer category. From there, anything over that needs to start having specialised breakaway couplings and such like on semi-articulated vehicles. And last but not least is gross combination mass. And that is the total the whole lot can weigh. Now, any one of these figures, on gross combination mass, it's the total amount that can be transmitted through the axles to the road surface when they're in trailer and tow vehicle combination. But that's not the only thing you've got to look at, because let's say in this scenario that was 6,000 kilos as a pick a number. All the axle capacities still have to fall within those legal requirements. So nothing else changes, it just adds another number that you need to comply with. It doesn't override any of the other manufacturer's requirements. All right, so that's hopefully busted a bit of the jargon for our listeners there.
So I've got a question here from Su Ying. GVM upgrading, does the trailer size impact its load rating?
Yeah, as I said earlier, the TA category trailer is single axle only, and that's up to 750 kilos. So if you've got a large single axle trailer, it's still okay and it can actually go higher than that, but it has to be braked.
John makes a question here. Tow ball download typically equals 10% of GTM. Would you like to comment?
No, tow ball download doesn't equal 10% of GTM. Tow ball download's typically 10% of aggregate trailer mass.
Thank you for the clarification. Are the rules the same across all of Australia? You mentioned some of the states. How much variance is there?
The gross combination mass field, there's quite a bit currently of difference around the states. Currently, on post-registered vehicles, I believe only New South Wales, Victoria and Tasmania accept gross combination mass upgrades. All the other states and territories post-registration are shying away from them. Now, I should say that as an aftermarket industry, we've put a technical working group together. So even though we're opposition, we work together for the good of the industry. And they're currently working through putting a submission to all state and federal regulators to try and get an industry standard for gross combination mass upgrades.
Across the whole country?
Across the whole country. Fingers crossed.
Question here from Samantha. How does the weight on the tow ball impact vehicle towing it?
We will touch on that later, but very quickly, it depends on the relationship of distance between the tow ball and the rear axle, but we will definitely cover that off a bit later on.
We'll hold that one over.
Okay, great. All right, chassis dynamics. So where you put weight and how much weight is obviously critical important. Now, I've just put this little picture up here, and this is weight loading 101 Nirvana. So this car has got nice low weight, it's nice and evenly balanced, and obviously when you go around the corner, it corners the same left to right, even though as you corner, the weight does shift from one side to the other. So let's look at something a little bit more real world, and the weight's a little bit higher. We've got some oil drums in there, and when you corner, obviously that weight shifts across. Now more than half the drums moved across, so the weight is shifting from one side to the other as you're cornering. So the center of mass versus the center of vehicle is changing, and obviously that amount of mass that moves depends on how much mass is in the vehicle and how high that mass is. And if you look at this image with a second oil drum on top, the bottom image has just got just over half a drum of oil shifting across to one side. The top one's 2/3. So the higher the mass, the greater the impact of that mass.
Does it matter if they're not quite as full?
Yeah, it would, because it's not shifting as much weight. But the issue with that is, if you've got an empty drum, then you've got fluid transfer freely. A full drum isn't sloshing around and creating that havoc. So we go back now, and then we'll look at another real world scenario. So if we look at a typical builder, let's say, and he's put his racks in the back, and you'll notice that the racks on the on one side are a little bit bigger than the other, and that's because in Australia, or in most cases, they tend to put the racks down the driver's side, and there's half as many racks down the passenger side because, of course, there's a sliding access door on the passenger side, so they can't fit as many racks physically in. Now that sets up straight away an imbalance in load. So now the center of gravity has moved up and across, and now the weight shift when you're cornering, because you're starting off to one side, is greater again.
Plus you'll have the driver on that side as well.
Plus you'll have the driver on that side. And he won't be 68 kilos, or not many of them are. All right, but that's, unfortunately, that's not where it stops. So this builder, he's off to a job, and he sent his apprentice past the timber yard on the way. And of course, it's got a roof rack on it, because they all do. And he's got his apprentice to get a heap of timber and strap it onto the roof. And thankfully, he did strap it, because he's a good occupational health and safety worker. So he's got that squared away. But what that does is, again, moves that center of gravity up higher and further across. And now that weight transfer is dramatic. And the cornering imbalance from left to right is actually physically noticeable. And one of the things that I had, even just a few weeks ago, I was on the way to one of our sites and I turned off the freeway and went to turn over, back over the bridge, and there's about a 8 or 10 tonne truck tray bed on its side. So it would have been turning that same corner at maybe 10 or 15k an hour. What he hadn't done was strap the load down. So that weight shift of the load was enough to roll a truck.
So just took it all with it.
Just took it all straight over. And that's the thing, that's what happens. And of course, the weight shift to the other side is less because the centre of mass has moved across to the right-hand side in this case.
It moves around pretty easily, doesn't it?
Yeah, it does. And as I said, that the higher that mass is, and you think a piece of 4x2 timber is about 12 kilos, you multiply that by the amount, and I'm sure we've all seen it as we're driving past a ute on the road with 20 or 30 of those pieces of timber up high on their roof. That's an awfully big change to the centre of gravity of that vehicle. All right.
So we saw a picture of the vehicle with all that mass on top of it. What sort of mass is allowed up there?
Again, most manufacturers, or a lot of manufacturers, have a roof load limit, and that can be anywhere from 40 kilos to 200 kilos.
And what about load restraint? How crucial is that to get it right, do you think?
Load restraint is obviously extremely critical. There are laws around load restraints, which I'm not an expert in. Ask me about weight, I'm happy to help, but strapping it down, there's specialists in that field that I would recommend people talk to if they're looking to move into that space or need that assistance in their workplace.
And there's, I think NTC has a load restraint guide as well for light vehicles, for those who are looking for some direction on that.
All right, suspension travel. So this vehicle image is actually a real world case study. It's not a mobile office, I'll give you that, but it's what we do see all day, every day, unfortunately. It's pulled into one of our stores in South Australia, and we weighed it because we've got scales in the sites. That's the legal maximum for gross combination mass, and it actually came in over 7,000 kilograms. With that 7,000 kilograms, made it over 1,300 kilograms overloaded. The weight, well, more than the weight of a small car actually. Suzuki Swift, I think, a curb weight at about 900 kilos. So it's about the weight of a loaded Suzuki Swift, overweight.
And you actually see this thing quite often out in regional Australia when you see vehicles loaded up like this.
Yeah, so this particular gentleman and his partner were pulled into South Australia, and they were on their way to Darwin, and they wanted a solution. The solution they were offered was probably not what they were looking for. They were offered a phone number of a tow company to take the trailer up to Darwin for them, because you just couldn't do anything that was safe and fit for purpose for it.
How do you find that as an organisation, when people come in or vehicles come in and you sort of see the mass and you see them overloaded like that? How does... You just shake your head. You know, look, you've got to be polite and respectful to the customer, of course, but it's just clear that the message isn't getting through, and it's one of the reasons I'm here today, because this sort of thing frustrates us from a company perspective, that part of what we believe that we need to do to be good corporate citizens is to educate as well, and unfortunately we failed in this case. So to give you an idea of that, the impact on that would be extreme, you know, across the whole vehicle. That just real quick short video here. This video was taken on a GoPro. It's only going for 10 seconds, but the amount of times that bump stop impacted, and that vehicle was loaded legally, and that was just on a short course at can't remember the name of the Motorsport park in Sydney, when we were doing some testing, and we were astounded. But they're designed to do that. That's why it's called a bump stop. It's designed to do that. It's not designed to do that all day, every day. And those sort of load transfers through that one single contact point leads to extra chassis fatigue and wear and tear, poor ride quality, and it's going to impact on brake performance and steering effectiveness and those sorts of things as well. So I guess key thing there is the vehicles are designed within small sort of thresholds.
They are, and they're designed, in fairness to the OEs, to to suit a broad target market. You've got to remember that a dual cab utility could well be purchased by someone for their family to drive kids to school. But it could also be that it's loaded up to the nines with tools and equipment all day, every day, and towing a bobcat. And the manufacturer doesn't know that when they make the car. So that's something that needs to be spoken through with the customer, either at point of sale or aftermarket with a specialist in that load carrying space.
I guess unless people are regularly weighing these vehicles or the vehicles are getting checked, it's out of sight, out of mind.
Exactly. You know, as I said, there is no gauge for suspension travel. There's no gauge for weight. So on suspension travel, and we touched on this earlier, we had someone ask what the impact of weight on the tow ball does to the towing vehicle. So in any case, depends where the weight is. Now, we've tested vehicles, and depending on the vehicle, this does change. But to give you a broad overview, 100 kilos worth of accessories on the front of a car can add 130 or sometimes more over the front axle, and that's simply weight transfer and leverage at work. Now, if you look to the rear, if you put 100 kilos on a tow bar, depending on how far that tow bar is from the centre of axle, it can double. So by the time that weight gets to the rear axle, you're now talking 200 kilos over the rear axle, and that weight has come off the front end. And as I alluded to earlier, it's about weight transfer, and taking that weight off the front means a reduced tyre contact patch on the front. Any weight, unloading of the front suspension means the front tyre isn't contacting the road surface as well as it should be. You've got to remember that the tyre contact patch on average is about half the size of an A4 sheet of paper, to give you a mental image. There's not a lot of road contact surface there anyway. So you want to try and keep as much of that over the front as possible. It's pretty important to be able to steer and brake.
And I guess that's right. It's just the pure lever factors is pushing it up.
Yeah, yep.
So we've got a question here from Gary. He was told by another organisation, unless I had a permanent load of 500 kilograms in a Land Cruiser 200 series, then the max GVM upgrade is 3,650 kilograms and not 3,800 kilograms. Standard GVM is 3,350 kilograms. Have you heard of this rule?
Gary, I can tell you I've never heard of that rule, and as a VicRoads signatory that is able to sign off on these things, it's not one that's crossed my desk as being accurate. I would have to double check that, but no, I've never heard of it at all.
One of the goals of this is to try and knock out a few of the uncertainties out there. So thank you for that one, Gary.
Yeah, and that's great, Gary, because I will double check that, and I might even get back to Jerome on that, see if we can get that back through the system for you.
Certainly. Question here from Matt, a second one. Why can GVM rating exceed the manufacturer weight limit on the axles?
That's a great question. What we do as an aftermarket or as anyone that's doing a GVM upgrade solution is we get, well, certainly I can only speak for our company, we outsource the engineering. So we go to an outsourced engineering company and we say, this is what we'd like to do with this vehicle. We'd like this capacity on this end and this capacity on this end. And they'll either say, all right, yep, that'll be X amount of dollars and we'll do a failure analysis on it for you. And then they'll come back to us and say, look, we're comfortable with increasing the rating of the rear axle to X. And the way they rationalise that is by doing a finite element analysis. Obviously, all components have a safety margin built in from the OEs. So in some cases, that's wider than others. But yeah, we always use an outside engineer to look at the capacities and see if there's any room for movement.
So it sort of covers you with that degree of independence as
exactly, yeah. We would never make an ambit claim about any of the ratings. We would always, and that's part of the reason that the aftermarket is getting the GCM looked at as an industry, because we don't want to make ambit claims about any of the ratings. We want to test that a standard we can all aspire to achieve with our kits, make sure it's safe and fit for purpose and ticks all the boxes.
Right.
All right, so wheel alignment. Now we spoke about weight and placement of weight and the leverage effect. Now obviously you put cargo in the back of the vehicle and it lifts the front. We spoke about that earlier. A simple weight transfer, but if we look at what that does to the critical alignment angles, depending on the suspension geometry, it's either going to lean the wheels in at the top, which is called a negative camber, and that will give you again a reduced tyre contact patch, and it will cause excessive wear on the inside edge of the tyre, because obviously the weight is going more so through the inside edge of the tyre. Depending, as I said, sometimes that will go through the outside edge of the tyre as well, depending on those critical alignment angles. Obviously, Nirvana, let's get as much of the tyre contacted to the road surface at all times. So I guess the takeaway here is once a car's loaded, the wheel alignment should be checked. Too often we have vehicles that are built, maybe even upgraded before they're registered, get a service body put on, they go off and the technician or the line serviceman or what have you puts 500 kilos worth of weight right in the back of it, lifts the front up a little bit, changes the front alignment angles, and they scrub tyres out. Or they don't stop, or they don't turn. So very critical to make sure that that alignment is specific to that load.
How does an organisation do that practically by themselves? Like if they're out in areas and there's not someone to check that, how does an organisation do that?
I think the industry's gotten smarter in that regard, in that certainly most of the participants in the industry that I know of, opposition included, now do what they call a recheck at 1,000 or 1,500 kilometres after they've seen the vehicle. So they get it back when it's been in service for 4 or 6 weeks and it's got all the load in it, and they do that recheck then. So that's part of what the good
practice.
It's good practice, yeah.
Okay.
All right. So one of the things that I'll just go back on, because it's a really good point, and thanks, John, for that, is manufacturers and changing axle ratings. So it's a common thing, aftermarket versus OE. You're never going to get a straight answer from either party, I don't think. We believe we're doing the right thing by getting the engineers to look at it and sign off on it. And the OEs are, and rightfully so, going to say, well, that's our standard. And if you go outside that standard, there's a possibility you'll void your warranty. We stand by our product, as do all the other big players in the aftermarket. He said, she said.
Okay.
All right. So following on from wheel alignment, the heavier any object, the harder it is to make it deviate from a set course. Now we touched on the alignment angle, so let's get this one in. So if we look at this, we'll just get some, there we go, we'll get some tyre contact patches up. We'll put some load in it. And that front tyre contact patch has reduced because the load has transferred to the rear. And that's straightforward. There's not a lot you can do about that apart from try and transfer some of the weight back to the front. But the other piece that now has reduced it even further is, of course, the misalignment that occurs that we just spoke about when that ride height does change. So the two possibilities here are probably to either mitigate or manage. To mitigate is to wheel align it. To manage is to move the weight further forward. And that, I guess that also mitigates it a little bit as well. So what does that do to the vehicle's safety and drivability and so on? What it does is, with a reduced tyre contact patch, you're trying to turn the wheels, and that weight is trying to go straight ahead. And the heavier the weight, the more it just wants to push on forward. So without sufficient weight over the front axle, the steering response is dramatically reduced. It results in what's commonly known as understeer, or the vehicle underreacting to the steering inputs, if you like. So you're trying to turn around a right-hand corner, and you have to actually put more angle on the steering wheel, the heavier the mass, because the mass wants to push it straight ahead.
Will you see the wear and tear in the tyres as well, if that's a regular occurrence?
Yeah, definitely. Yep. And again, depending on misalignment, you'll see outside edge wear on excessive cornering with excessive load, and tyre pressure plays a part. When you'll see on the side of any tyre, they've got a load PSI rating or KPI rating, and that changes depending on the load. There's also tyre placards on all vehicles that I can think of that also give you that guideline. So if you're carrying weight, if you're putting a caravan on to go away for the weekend, then you need to look at those tyre pressures as a part of that package.
When vehicles come in to your depots, what sort of variance do you see with regards to tyre pressures?
Anything from 15 to it's one that doesn't get checked anymore, you know. And unfortunately or fortunately, I'm old enough to remember the days when you'd pull up at a service station, someone would actually fill the car up for you and check the tyre pressures while it was filling. That doesn't happen anymore, and tyre pressures frequently only get checked when someone walks out and sees that it looks too flat, or when a car's getting serviced.
And what do you think? Do you think organisations care much about that as well?
I think it's something that could probably be looked at more regularly, or perhaps even part of a weekly walk around or routine on a vehicle for sure.
There's just, I guess, a bit of a statement looking for a comment from you from Bree. I understand that an overloaded sector vehicle in an accident voids insurance. Could it also lead to other charges if someone was injured or killed?
I'm not an expert in the legal field, but I would think that if you knew that there was an issue with your vehicle, and it goes back to workplace health and safety, as far as is practicable, if you knew there was an issue and you chose to do nothing about that issue and it caused serious injury or fatality, then I'm pretty sure the coroner would look seriously at that if it came across their desk, yes.
And just a bit of a carrot for you as well, Bree. NRSP will be releasing in the coming weeks a document called Light Vehicle, Legal Implications for Businesses, with a whole series of hypotheticals at the back, which has been drawn from the Dean of Law at Flinders. So keep your eyes out for that.
All right, last but certainly not least, braking efficiency and distance. So the impact of weight on braking distance. Let's have a look. So from empty, so we talked about curb weight earlier, to full GVM, at 60 kilometres an hour, this vehicle, and I've calculated the mass at just on 2,000 kilograms, which is average for that sort of range vehicle, is going to take 11.1 metres longer to stop at 60 k's an hour. When you think that the average pedestrian crossing is 2 metres, give you a mental picture of how much further it's going to take to stop. At 80 kilometres an hour, that goes to nearly double at 19.8 metres, and 100 kilometres an hour, we're now up to 30 metres. Exactly the same vehicle, exactly the same brake system, exactly the same brake pressure. Where that becomes an issue is in this mobile office space, because these dual cab utilities and such, like commercials, are really common these days. And the issue is that a lot of people are driving these to work empty because it's their toy truck. They get out, they get in exactly the same make, model and brand of vehicle, but like slide 2, it's got a full service body build on it and it weighs 1,200 kilos more. It's going to handle completely differently, stop completely differently, and people need to be aware of that, and it needs to be brought more to people's attention in the fleet space that you're driving something that is 3,500 kilos or whatever that figure is, and it's not the same vehicle even though it looks the same.
So your headspace is in the lighter vehicle whilst you're driving a heavier vehicle.
Yep. Because the dash and everything you're seeing, your occupant experience is identical until you go to turn or hit the brakes. So if we now look at it with a trailer, exactly the same vehicle, and remember earlier we said that the maximum unbraked trailer capacity is 750 kilos. So let's add 750 kilos to that scenario, and it's going from 11.1 metres to just under 20. So about 8 metres roughly, that trailer is pushing that further. Let's move up to the 80 kilometres an hour. From 19.8, we're out to 35 metres. So a substantial difference.
That's just 80 k's.
At 100, we're from 30 out to nearly 55 metres. And that's where, you know, the TAC and all that information piece around leaving enough space and 2-second stopping distance and such are really critically important. So any questions there?
We've got a few actually. So Andrew wants to know, how are impacts of increased wheel rim sizes on the light commercial vehicle?
Okay, so wheel and rim tyre size is controlled by VSB 14, which is a document for light vehicles for modifications, and the wheel and tyre must still match or be superior to the original ratings. All tyres have a load rating. Rims are load rated as well, so they have to match or beat that. But there's also regulations around increase in diameter and width.
Thanks for that. Got one here from Kumar. Slightly different question related to upgrade of brake pads, slides 1 through to 8. Are there any solutions available to reduce brake failures of loaded trucks when travelling on a long, steep downhill slope? This can result in a significant safety issue on some rural highways.
Yeah, hi Kumar. We actually saw that on the news just this week. I think a truck going through the Adelaide Hills had to divert into the sand trap. There's no real answer to a heavily loaded truck. It's about
the arrestor bed.
Yeah, well, it's also about management of the heat. What a braking system does is transfer motion into heat. So it's about managing that heat.
Yeah, those gears right when you're going down.
Yeah.
Question here from John. I worked on a case where a vehicle was rated to tow a 3.5 kg trailer. They only used a 550 kilogram trailer to tow a 1800 kilogram load. Transmission would overheat, so driver had to do it at a minimum reduced speed, or whether there was a clearance stop and wait for temperature to drop. In the end, the official tow bar fell out of the chassis. Who was responsible? It's a big question, that one.
That is a big question. Thanks for that, John, right at the end. Just getting my head around this. It's probably not one I have the wherewithal to answer straight away. If I had to give an answer off the top of my head, I reckon I'd be wrong. So I'm going to pass on that one, Jerome, because if I'm going to give a response, I want to be confident that it's going to be the correct one.
Okay. We'll hold that over. Thank you, John. I guess the next sort of point we'd like to make is the Australasian Fleet Management Association will have a drive day on the 22nd of May. Do you want to tell us a bit about that, Dave?
Yeah, so Mace and his team at AFMA, as I call it, are putting on a drive day at Sandown Raceway. So we will have half a dozen different types of vehicles with all different loads and suspension setups. So, and we'll be running through some key critical exercises on the actual raceway to show people the impact of weight. So we'll have a standard vehicle with no load, we'll have a standard vehicle loaded to the original capacity, and then we'll have a vehicle with an aftermarket, obviously Pedders suspension kit, going through the same exercises so people can physically for themselves feel that impact and understand how you can mitigate the risks around poor handling that result from load carrying.
Excellent.
Along with that, there will also be, I believe, low emission vehicle displays and demonstrations and advanced driver assist system demonstrations and drives. So should be a great day, apart from the fact that it's mid-May and fingers crossed we get some good weather.
We'll put that out there for the powers that be to make a decision on that one. So thank you very much for your time, Dave, and thank you very much to the audience, to all of you coming in. So please keep up to date of our news and go to the NRSP website, register for our newsletter, and you'll be kept informed of all the up-and-coming webinars, events, and that legal implications paper that will be coming out soon. So thank you very much, Dave.
Thank you.
And thank you again to our audience. Have a lovely week. Thank you.